Hi, so for today we're going to talk about tangent and normal lines, slope of curves, and this is a part of the application of derivatives, and this is still a part of differential calculus tutorial in our series of differential calculus. So we have several problems here involving how we are going to determine the slope of a curve, how are we going to um, get the point where a certain curve has a certain slope, and how are we going to get the equations of the tangent and normal lines to the curve at a certain point. So if you want to learn, okay, how to solve this type of problems, let's get started. Okay, so just tune in to our discussion. So for number one, it says find the slope of the curve y equals 1 minus 2x cubed at 1 negative 1. So we know that the slope is actually the first derivative, okay? So actually that is the definition of slope, the first derivative. So we have 1 negative 1 here. So we're going to find the slope of this curve, okay? At this point, 1 negative 1. So what are we going to do first is to get the derivative of this with respect to x, of course. So we have 3. We have 1 minus 2x, 3 minus 2, okay? 3 minus 1, I mean, okay? And then, we differentiate the inside function, which is 0 minus 2, okay? So 0 because of the first term, and negative 2 because of this negative 1 minus 2x, okay? So simplifying, we have 3, okay, we have negative 2, 1 minus 2x squared. So we have negative 6, 1 minus 2x squared. So we have already differentiate, okay, the y prime. And if we are going to substitute the value of the given point of x, which is actually this value, this one, okay, so what are we going to do is to actually substitute that value to get the slope. So we have negative 6, 1 minus 2 times 1 squared. Okay, we know that this would be negative 6 and 1 minus 2, okay, times 1 is still 2. 1 minus 2 would become negative 1, but it is squared, okay, so that we have negative 6 times 1, which is negative 6. So this y prime equals negative 6 is the slope that we are trying to get, okay. We know that in analytic geometry, this m denotes slope. So that is the slope of that curve for number 1. How about for number 2? For number 2, determine the slope of the curve y equals 6, 6, 4 plus x raised to 1 half at the point 0, 12. Okay, 0 and then 12. So what are we going to do again is to differentiate. Okay, so upon getting the derivative of this would be 6 multiplied by 1 half. This would be 4 plus x 1 half minus 1. Okay, let me just rewrite the 1 half. So that would be 1 half minus 1. And then differentiate the inside function with respect to x. So this becomes 0, but the x becomes 1. So technically, we have y primes. 6 divided by 2 would be 3. Okay, so we have 3 times 1. Okay, times 4 plus x. 1 half minus 1 is negative 1 half. Okay, so technically, we have 3 all over. We have 4 plus x raised to 1 half. We have used the exponential property to eliminate the negative by having its reciprocal here. Okay, so this is also equal to 3. We know that 4 plus x raised to 1 half is equal also to square root of 4 plus x. So that is our y prime. To get this slope, okay, we substitute the value again of this x. So what will happen? We have y prime. Our x is 0 at the point 0, 12. So we have 3 all over square root of 4 plus 0, or 3 all over square root of 4, or square root of 4 would be 2. So the slope of that curve at this point, okay, would be 3/2. Okay, this is the slope. Okay, because we are asked to find the slope. Number 3, find the slope, okay, of the curve y equals x squared multiplied by x plus 1 cube at 1/8. So we have number 3. So we have, what's that again? X squared, y equals x squared, x plus 1 cube, okay, at 1/8. Okay? 1/8 at the point 1/8. So the same process we are going to do here, but take note that this is the derivative of a product since we have x squared multiplied by x plus 1 cube. So what are we going to do? We have y prime. We can first copy the first term here. So we have x squared, and then we are going to differentiate x plus 1 cube. Okay? And then plus, okay, copy the v. We can label this as our u, and this is our v. So we can copy the v, x plus 1 cube, and then differentiate the x squared. Okay, so that's the product rule. So we have x squared multiplied by the derivative of this. So we have 3. We have x plus 1 squared. Differentiate the inside function. So we have 1 with respect to x. Then plus, we have x plus 1 cube. Differentiate this, we have 2x. Okay, so we have 3x squared, x plus 1 squared. Then we have 2x multiplied by x plus 1 cube. Okay, that is our y prime. So to get the slope of this curve at 0.18, okay, we need to substitute this value of x, okay, in our equation. So we have 3 times 1 squared. So we have 1 plus 1 squared plus 2 times 1, and then we have 1 plus 1 cube. Okay? So it's very easy. This would be 3. This would be 2 squared. This would be 4. Okay? And then we have 2. 1 plus 1, 2 cube would be 8. Okay? So we have 12 plus 16. That would be 28. And this would be our slope. Okay? That's the slope of the curve at that point, 1/8. Okay, let's try number 4. Okay? Determine the slope for the curve y equals 1 minus 2x squared all over x at 0.11. So we have 4, we have y, 1 minus 2x, that would be 1 minus 2x squared all over x. All over x at 0.11. Okay. So, again, this is another rule. Okay, we practice product rule on the previous number, but here we're going to practice the quotient rule. Okay, so we have y prime. So we have the formula low d high minus high d low over low squared. So that's the mnemonics. So we're going to copy this and differentiate class the numerator, then minus high, copy the numerator and differentiate the low, all over we squared the denominator. Okay, so let's try. We have y prime, we have x. Get the derivative of this. That's 2, 1 minus 2x, and then negative 2. Minus, we have 1 minus 2x squared. Differentiate x, which is 1. Okay, all over x squared. So simplifying, we have negative 2 times 2. That would be negative 4 times x. Negative 4x, 1 minus 2x. And then we have 1 minus 1 minus 2x squared all over x squared. So we substitute. To get the slope, we substitute the value of x at that given point, 1, 1. So the value of x in that case would be 1. So we substitute the value of x equals 1. So that becomes what? We have negative 4 times 1, 1 minus 2 times 1, minus 1 minus 2 times 1 squared all over 1 squared. Okay, so this would be uh, having no denominator because we have 1 squared. So we have negative 4 here. We have 1 minus 2 times 1 is 2. So 1 minus 2 would be negative 1. Then we have minus. This would be the minus. So 1 minus 2 is negative 1 squared. So that becomes positive 1. But we have a minus here, so we have 1 here. Okay? So 1 minus 2 times 1 is negative 1. It's squared, so it becomes positive 1, and we have negative here, so this becomes negative 1. So 4 times negative 1 becomes 4, okay? Minus 1, that would be 3. And this would be our slope for the given problem. So for number 5, at what point does the curve 3x squared minus 7x plus y equals 0 have a slope of 1? So in this given equation, okay, in this given problem, we are no longer getting the slope because the slope is actually given, which is 1. What are we going to find is the point wherein the curve has a slope of 1. Wherein this curve, 3x squared minus 7x plus y, has a slope of 1. Okay? So that's what are we asked for. Okay? So let me just, instead of rewriting this, let me just copy this. Okay? Okay, that is the problem number 5. Okay. So we are given with a slope. Okay. Again, our slope is 1. And we know that by definition that the slope is equal or equals y prime. Okay. So we are given with the curve. We have 3x squared plus or minus 7x minus 7x plus y equals 0. So what are we going to do is to differentiate. Okay? So we would be treating y, okay, if we differentiate with respect to y, okay, we are actually getting the y prime. So we have 6x minus 7 plus y prime equals 0. So this is our first differentiation. And we know, class, that y prime equals the slope. And according to the problem, the slope is 1. So we can simply substitute y prime with 1. 6x minus 7 plus 1 equals 0. And then finally get the value of x. Okay, isolate x. So we have 6x. We have negative 6 equals 0. So we have 6x equals 6. So our x would be 1. Okay, that's 1 point. That is our x. How about uh, getting the point y? We will go back to the original equation and substitute the value of x that we have got, okay, to find the value of y. So substituting x here. So we have 3, 1 squared minus 7 times 1 plus y. We are going to get the value of y here to get the points. So we have 3 minus 7 plus y equals 0. So this is negative 4 plus y equals 0. Y equals 4. So the point wherein this curve will have a slope of 1 is actually 1 and 4. 4. So we have 1 and 4. So this is actually the answer. Okay? So that is the point. Okay. So how about for number 6? Okay. Same process because we are asked to find the point. Okay. So this is problem number 6. Okay. So at what point does the curve x cubed minus 9x minus y have a slope of 18? The same process that we are going to do, class. So differentiate, we have 3x squared minus 9. This becomes minus y prime equals 0. We know that y prime equals the slope, and the slope that is given is 18. So we have 3x squared minus 9 minus 18 equals 0. Okay? So, 3x squared minus 27 equals 0. And then what are we going to do? We are going to get the value of x. So we have 3x squared equals 27. So x squared, 27 divided by 3, that would be equal to 9. So getting the square root of both sides of the equation, so x would be equal to 3. Okay? So our x is 3. And then to get the y, we substitute x equals to 3 to the original equation, x cubed minus 9x minus y equals 0, to get y. So we have 3 cubed minus 9 times 3 minus y equals 0. So this would be 27 minus 27 minus y equals 0. So 0 minus y equals 0. So in other words, we have y equals 0. Okay? If we are going to uh, transpose this negative y here. So y equals 0. Okay? So the points are 3 and 0. That is the point. This is the final answer. That is the point wherein this curve will have a slope of 18. Number 7, last problem for this. Okay? So that we can learn something. Okay? And we practice our skill. 7. At what point does the curve x cubed minus 3x minus 3y equals 0, okay, has a slope of 3? So we know that the slope is 3. That is y prime equals 3. So differentiate. We have 3x squared minus 3 minus we have 3y prime equals 0. Okay? So we have uh, differentiate with respect to y. Okay, so we now have to substitute the value of y prime, which is equal to the slope, which is 3. So now we have 3x squared minus 3 minus 3 times 3 equals 0. And then we're going to get the value of x. So this would become negative 9. So this would become negative 12. Okay, negative 3 times 3, negative 9. Negative 3 minus 9 is negative 12 equals 0. So now we have 3x squared equals 12. So x squared would be 12 all over 3, which is equal to 4. Get the square root of both sides. So we have x equals 2. That would be our point. Okay? So we're going to substitute x to the original equation here. So to get y, so we have 2 cubed minus 3 times 2 minus 3y equals 0. Okay? So this would be 8 minus 6. Okay, and then we have 3y here. So this would be what? 2 thirds equals y. So y equals 2 thirds. So this would be our y. So the point is 2 and 2 thirds. This is the final answer for this problem. This is the point wherein this curve will have a slope of 3. So for number 8, let me just copy this one. Find the slope of the tangent to the curve y equals 3e raised to 2x at 0, 3. So we are asked only to find the slope. Okay? So just like the previous examples that we have done, okay, we simply get the first derivative and substitute whatever the value of x to get the slope. Okay, so we have y equals 3e raised to 2x. So get y prime. So we have 2 times 3e raised to 2x. Why do we have 2? Because if we differentiate 2x, that would be 2. And this is multiplied by the whole equation, multiplied by the original equation. So that we get y prime 6e raised to 2x. Substitute x equals 0 because of x here. So we have y prime. We have 6e raised to 2 times 0. 2 times 0 is 0. E raised to 0, any number raised to 0 is 1. So this becomes 1. So that would be 6 times 1 or simply 6. And that is our slope. Okay? So that's the answer for our problem number 8. So how about problem number 9? Okay. So for the problem number 9, find the equations of tangent and normal to the curve y equals x cubed at the point 2 and 8. So we are going to find the tangent line, okay, to this curve, tangent line to this curve, and normal line to the curve. When we say normal line, it's actually the perpendicular line, okay, at this curve at this very point, 2, 8. Okay? So, first things first is we are going to find the derivative of this so that we get the slope because we are asked to find the equation of the tangent line and the normal line. So we need to have a slope because we have what? 2 points here. We can use the point slope form to get the uh, tangent and normal line. Okay? So we differentiate y equals x cubed to get the slope. And at the same time, we use this point slope form to get the equations of the tangent and the normal to the curve. Okay? So first things first, we have y equals x cubed. Differentiate that, that would be 3x squared. To get the slope of that, okay, tangent, okay, line, at this point, 2, 8, we need to substitute again the value of x. So that we have 3 times 2 squared equals, that would be 3 times 4, that would be 12. Okay, this is the slope. And we can now use the point slope formula for our lines to get the what? The equation of the tangent line at that curve. So we have y minus, we have our x and y here, x sub 1, y sub 1 here. So we have 1, y minus 8 equals 12. And then we have x minus 2. Okay? So, simplify. We have y minus 8, 12x minus 24. Okay, transposing all of this left side to the right side. So, we have negative y plus 8 equals 0. So, we have 12x, okay, minus y, negative 24 plus 8 would be negative 16 equals 0. So, this is the equation of the tangent line. Okay? Tangent line to the curve. Okay, this curve at this point. So how about we get the normal? Okay, normal to the curve. So simply, okay, this normal to the curve is perpendicular to the tangent. Okay, so we know that if we have parallel lines, let's say m sub 1 or line 1 and line 2, if they are parallel, okay, parallel, they have the same slope. Okay? But if L sub 1 and L sub 2 are perpendicular, they have the negative reciprocal of each other. Okay? And that is what the normal line is. It is perpendicular to the tangent line at this point. So what are we going to do since we have already the slope of the or of the tangent? So we will be getting the slope of the normal line, which is the perpendicular slope of this line. So we have negative 1 all over 12. And this is the slope of the normal line. Okay? So the negative perpendicular, negative reciprocal. So still, the same points that we are going to use, the same equation, but this is the slope of the normal since we are already getting the normal line. So we have y minus y sub 1. Oops, let me substitute it. So we have y minus 8 still, And our slope would be negative 1 all over 12. And then we have x. Sorry, this is x, not y sub 1. So this would be x. X minus x sub 1. And also this. Okay. So you have x minus, this would be 2. Okay. So simplify. So we have 12y. Okay. And then minus 12 times 8. So 12 times 8, we have 16, 1, 8, 96. Okay. And then distribute the negative 1 here. So this becomes negative x, then positive 2. So transposing this to the left side. So we have x minus 2 plus 12y minus 96 equals 0. So we have x plus 12y, negative 2 minus 96 would be negative 98 equals 0. So this is now the equation of the normal line. Okay? Normal line to the curve at the point 2a. Okay? So down to our last problem, the same type of problem. We're going to find the equation of the tangent and normal to the curve. Okay, let me just copy the question. Oops. So this would be our final question here. Find the equations of the tangent, normal to the curve y equals 3x squared minus 2x plus 1 at point 29. So the first thing that we're going to do is to get the derivative of 3x squared minus 2x plus 1 so that we get the slope since we have, again, a point. So we have 6x minus 2. So to get this slope, we substitute the value of x, okay, at that point. So we have 6 times 2 minus 2, and that is equal to 10. That equals 10, okay? And this 10 would be our, again, slope. And we are going to use, again, the point slope form to find the equation of the tangent, okay? First tangent line on this problem. So we have y minus our y here, y sub 1 is 9. Then we have 10. We have x. X sub 1 here is 2. Okay. So simplifying, we have 10x minus 20. So we have 10x minus 20 minus y plus 9 equals 0. So you have 10x minus y minus 11 equals 0. So this is the equation of tangent line. Okay. So how about the equation of the normal line? So since the slope is 10 of the normal line, so we will get the slope of the normal line by getting the negative reciprocal of that slope. So that becomes negative 1 all over 10. So and we're going to use the point slope form again to get the equation of the normal. So we have y minus, again, 9. And then we have negative 1, 10, the negative reciprocal of the slope of the tangent. So we have x minus 2. So simplify, we have 10y minus 90, okay, by multiplying 10 both sides. And this negative would be distributed here, negative x plus 2. So we have x minus 2 plus 10y minus 90 equals 0. So we have x plus 10y minus 92 equals 0. So this is now the equation of the normal line. That's it, and I hope you learned something for today's video. If you are new to my channel, please don't forget to subscribe and hit the thumbs up on this video. This is Engineer Abat, hoping that you are safe, and see you again on the next video. God bless.